says that a rock is thrown straight up with a velocity of 28 meters per second from the edge of the building, just misses the building as it comes down. The rock is moving 60 meters per second when it strikes the ground. How tall was the building? And we see it gives us the acceleration due to gravity. Now, it would really help us here if we gone ahead and pictured what was happening. So here's our building, and here's our guy standing on top of the building, and basically there has a rock right here, and he throws it straight up, and it comes down. Okay, now at the very beginning, so right here, it has an initial velocity of 28 meters per second. And then way down here, it has a final velocity of 60 meters per second. Now, the one thing that we have to understand is that basically he's actually throwing the ball from this point right here. And so when we're looking at it, what we can say is that this initial velocity of 28 meters per second is also going to be the same velocity. If you threw it from right here, it would be the same velocity at the top of the building, so the start of the building. So what we're going to do is we're going to use this 28 meters per second as our initial velocity. And this 60 meters per second is going to be our final velocity. And then we also have our acceleration, which is 9.8 meters per second squared. Okay, these are the variables that we have to work with. Now, the equation that we're going to use, okay, if we have if that, okay, we have initial, we have final, we're searching for distance, we have the acceleration. We're going to use the equation that does not have time, which we know that that equation is going to be our acceleration equals our final velocity squared minus our initial velocity squared all over 2 times our displacement. Okay, so when we're looking at this, if we're looking for the height of the building, we're going to look at our displacement. And so therefore, all we have to do, rearrange this equation, and we switch the D and the A, so we get our, all we're going to get is our displacement equals our final velocity squared minus our initial velocity squared all over 2 times our acceleration. And then all we have to do from here is just plug in our variables that we have. Okay, so we take what we have and we go distance equals, our final velocity is going to be 60 meters per second. We square that. And we go minus our initial velocity of 28 meters per second squared all over our 9.8, or 2 times 9.8 meters per second squared. Okay, and that's what we have. Now, one thing that we have to understand, these velocities, they are going down, so they are negative. Remember, our acceleration will be negative, but anytime that it asks for how tall something is, you're going to have a positive number. You want the magnitude of it, because you can't be negative meters tall. Okay, so anytime it asks for how tall something is, it wants the positive value of that. And what we would end up getting once we plug this in the calculator, I get something right around 143.67 meters. Make sure that you pay attention and put your numerator and denominator in parentheses if you're plugging it all in the calculator at once.